towards their substrate. This specificity arises because an enzyme molecule has a binding area which recognizes and binds the substrate. The specificity, so in short, is of central importance in the control of metabolism in living organisms. In some instances, enzymes may bind substances which are not substrates. In this way, the active site of the enzyme molecule may be blocked or may become distorted. The enzyme is then said to be inhibited. The specificity of an enzyme in a metabolic pathway and the potential for its inhibition provide organisms with mechanisms for the control of metabolic pathways. Enzyme specificity is employed in hospitals and in industry for the analysis of single components of mixtures without need for their isolation, and also for the catalyst of single specific reactions. Inhibition of an enzyme is used as a tool for the study of its mechanism of catalysis and represents the mode of action of many pharmaceuticals.
Okay, pharmaceuticals. So what they're saying is you have a number of different uses for enzymes. So they're used in the hospitals to do certain things. And again, we're just going to look at either they're going to start something, speed up something, or it's going to block something. So general note, some of the chemicals used in the following tests may be poisonous. So you've got to remember your safety rules and procedures. Now, I have already diluted everything to the point of it's not going to matter, but still, you're not going to go back there playing and doing all types of things knowing that you know what the proper safety precautions are. And please make sure that you adhere to them when you go in the lab. Do not breathe in powders or allow them to blow around. Again, you're not going to have that problem because we have already set up everything for you. Your stock solutions are over there on the counter to the left. Your individual test tubes and site areas are on those stations. Now, over here, you're not going to go in this area here over to the right because that is for the experiment from yesterday, and I think one or two people need to do something over there, but we are not going to do that now. So today we're going to concentrate on enzymes. Go to the next page, please. Okay, now here you have in front of you your materials for the lab. So you have different concentrations of the sugars, bless you. So we have glucose, maltose, lactose, sucrose, bless you. Go to the next page, please. Now look at procedure 1. This is where we are going to begin. To each of our 4 test tubes, add 8 drops of 0.5 milliliters of invertase. Okay, it's ending in ASE. What do you know about substances that end in ASE? Can you remember? It's an enzyme. Thank you. And enzymes are proteins. So that's correct. To one tube, add 0.5 milliliters of sucrose. To another tube, 0.5. To another 0.5 lactose. So basically what they're saying, the standard that you're going to use is 0.5 milliliters. I'm going to leave that up there because I know it's with yesterday, even though I said and even though I gave you a demonstration, some people still did not have a clue as to what you were doing. But it's one thing to say something and one thing to do it and another thing to read. So again, you will never go into the lab without understanding what you are doing, and you should never conduct the experiment if you don't know what's going on. What happens if you put 1 milliliter, 4 milliliters, 5 milliliters, and they only ask for 0.5? Do you think that's going to have an adverse effect on your experiment?
Yes.
What do you think could happen?
It could blow up.
The experiment wouldn't work out because you put it too much liquid in it.
Okay, so all types of things could happen, and we don't want that. We want the correct ratios. We want the correct results. So how much of each type of sugar are you, or solution are you going to use?
0.5.
0.5 milliliters. So what are you going to measure the little milliliters in? What's on your table that you can use? We're going to use the graduated cylinders. Thank you. Now, some pipettes are calibrated, meaning that it's marked on there for you could actually use what you need to, but we may not have that. So I'm going to say and suggest that you use your graduated cylinders. Again, and I will put those things on the side over there in the middle. I want you all to stay at this one area over here. Let's see. No more than 3 people in a group. And you're going to spread out. Now it says again, to each of the 4 test tubes, add 8 drops of 0.5 milliliters invertase solution. And is that a carbohydrate or is that a protein? It's a protein. How do you know it's a protein?
It ends in ASC.
It ends in ASC. Okay, so to 1 tube, add 0.5 milliliters of sucrose, to another 0.5 milliliters of maltose, to another 0.5 of lactose, and to the 4th, you're going to do starch. Now, what I'm going to tell you to do is you need to make sure that you label your test tubes. Why is it important to label the test tubes?
So you don't put something twice or get confused.
Exactly. Now, don't mess it up now. Remember, you're telling me exactly what you're going to do. You're telling me the correct things. But sometimes when we go in the lab, what happens? So again, we've got to read. We've got to go in order. And so we're going to leave those sit for 10 minutes. Time is a factor. Test each solution with a reagent strip. Now the reagent strips are back here as well. Here are your reagent strips. And if you look on the pack, the reagent strips are color-coded. So once you put it in there to see the reaction, you're going to match up the colors. What is that going to tell you? The concentration. So again, you've got to take 1 strip, put it in there, and test and record.
Is it like those drops we put in yesterday?
Okay, yesterday you used the drops and you got the color indication. But now, what else? Do you know what else you could use that we've used before that gives you a color indication and you match it up and it tell you something?
We did.
Anybody?
Like what we did yesterday.
What have we done in the past in which you have to match it up to give you a color indication based on a number or anything?
Oh.
pH. Thank you. And what else?
Lipids.
The lipids. Litmus paper. So it's a number of different things that you could use. But
Then we had to watch, I can't remember the exact thing, but I remember when we conducted the experiment and we had to wait for it to break down on the little strip.
okay. So here you are now. Before we did an enzyme virtual lab. So now you have the actual hands-on. Again, this is review. It's a lot, but it's one thing to say something and another thing to do it. Now remember, when you come back here, I'll be watching to see that you have the correct procedures. You're following the safety things correctly, and you're following your procedures. And I'm going to stop here.